G9A feed lines, characteristic impedance and attenuation, standing wave ratio, SWR, calculation, measurement, and effects, antenna feed point matching. G9A01A. Which of the following factors determine the characteristic impedance of a parallel conductor feed line? A. The distance between the centers of the conductors and the radius of the conductors. B. The distance between the centers of the conductors and the length of the line. C. The radius of the conductors and the frequency of the signal. D. The frequency of the signal and the length of the line. G9A02B. What is the relationship between high standing wave ratio, SWR, and transmission line loss? A. There is no relationship between transmission line loss and SWR. B. High SWR increases loss in a lossy transmission line. C. High SWR makes it difficult to measure transmission line loss. D. High SWR reduces the relative effect of transmission line loss. G9A03D. What is the nominal characteristic impedance of window line transmission line? A. 50 ohms. B. 75 ohms. C. 100 ohms. D. 450 ohms. G9A04C. What causes reflected power at an antenna's feed point? A. Operating an antenna at its resonant frequency. B. Using more transmitter power than the antenna can handle. C. A difference between feed line impedance and antenna feed point impedance. D. Feeding the antenna with unbalanced feed line. G9A05B. How does the attenuation of coaxial cable change with increasing frequency? A. Attenuation is independent of frequency. B. Attenuation increases. C. Attenuation decreases. D. Attenuation follows Marconi's law of attenuation. G9A060. In what units is RF feed line loss usually expressed? A. Ohms per 1,000 feet. B. Decibels per 1,000 feet. C. Ohms per 100 feet. D. Decibels per 100 feet. G9A070. What must be done to prevent standing waves on a feed line connected to an antenna? A. The antenna feed point must be at DC ground potential. B. The feed line must be an odd number of electrical quarter wavelengths long. C. The feed line must be an even number of physical half wavelengths long. D. The antenna feed point impedance must be matched to the characteristic impedance of the feed line. G9A08B. If the SWR on an antenna feed line is 5:1, and a matching network at the transmitter end of the feed line is adjusted to present a 1:1 SWR to the transmitter, what is the resulting SWR on the feed line? A. 1:1. B. 5:1. C. Between 1:1 and 5:1, depending on the characteristic impedance of the line. D. Between 1:1 and 5:1, depending on the reflected power at the transmitter. G9A09. A. What standing wave ratio results from connecting a 50-ohm feed line to a 200-ohm resistive load? A. 4:1. B. 1:4. C. 2:1. D. 1:2. G9A10D. What standing wave ratio results from connecting a 50-ohm feed line to a 10-ohm resistive load? A. 2:1. B. 1:2. C. 1:5. D. 5:1. G9A11A. What is the effect of transmission line loss on SWR measured at the input to the line? A. Higher loss reduces SWR measured at the input to the line. B. Higher loss increases SWR measured at the input to the line. C. Higher loss increases the accuracy of SWR measured at the input to the line. D. Transmission line loss does not affect the SWR measurement.